Friends, DevOps, SREs, lend me your ears. I come to bury AppSec, not to praise it. And this opening Shakespeare bit isn't going in the right direction, is it? That's why you should beware the developer IDEs of March. Noted. Which means this week we talk with John Morello about the importance of a cloud-native strategy for enterprise security and how much that strategy needs to integrate with DevOps tools and processes. In the news segment, F5 hits some toil and trouble. Backtracking regexes show fair is foul and foul is fair. SigStore asks, what's in a name? While Spectre leaves browsers in a winter of discontent, and more. Cry havoc. And stay tuned for Application Security Weekly.
This is a Security Weekly production. It's the show to learn the latest tools, techniques, and processes necessary to understand DevOps, application security, and cloud security. Your trusted source for the latest application security news. It's time for Application Security Weekly. In a fast-paced tech environment, the potential attack surface increases with each release and new app created. Detectify automates cutting-edge knowledge from trusted ethical hackers into the development pipeline for reliable application security. Go beyond the OWASP Top 10. Check your web apps for over 2,000 known vulnerabilities actively exploited in the wild, monitor subdomains for potential takeovers, and remediate security issues in staging and production. Learn more with a free trial at securityweekly.com/detectify. Go hack yourself. Security teams need visibility into Linux systems to detect and investigate incidents and protect against unwanted activity. Operations teams are not down with downtime, and with revenue tied to uptime, ops priorities are enterprise priorities. Which is a higher priority? Why not both? Capsulate provides flexible, production-ready infrastructure protection for Linux systems, all without a kernel module. With ops-friendly production security, Capsulate delivers monitoring, detection, and response without adding operational risk or cost. Visit securityweekly.com/capsulate today to request a demo.
This is episode 143, recorded March 15th, 2021. I'm your host, Mike Shima. I'm here with Adrian Sanabria. Hello, Adrian.
Hey, good to see you again, Mike. You promised more puns and have already delivered in the intro.
I thank you for staying here. Good to see you back with us, and good to have you back with us in the loop on all things Security Weekly as well, which all of our listeners can do by subscribing to at securityweekly.com/subscribe on your favorite podcast catcher or our YouTube channel, sign up for our mailing list, and joining our Discord server. And if you missed the Security Weekly Unlocked, you can now access all of the content on demand by visiting securityweekly.com/unlocked. You'll find plenty of informative discussions among the offensive, defensive, and strategy and culture tracks. John Morello is the VP of Product at Palo Alto Networks and the former CTO at Twistlock. Prior to that, John was a CISO at a Fortune 500 global chemical company. Before that, he spent 14 years at Microsoft in both Microsoft consulting services and product teams. He ran feature teams that shipped security technologies in Windows, Azure, and Office 365, and was the lead consultant on several security projects at the White House. John lives in Louisiana with his wife and 2 young sons, a passionate fisherman and scuba diver. He's also a longtime board member of the Coalition to Restore Coastal Louisiana. Hello, John. Thank you for joining us.
Hey, thanks for reading my bio.
Well, thanks for joining us so we can dive in to a whole bunch of things about cloud security. And I guess I want to start off with the idea that cloud security is sort of an easy phrase to say, but I think it's a bit more complex with that, with quite a few problems and quite a few that DevOps teams have to deal with. So one of the things to kick us off with is, how do you kind of organize or categorize these problems? And more importantly, perhaps, how do you go about finding solutions that would work well in this space?
Well, I tend to think about cloud security as being 3 layers. The bottom layer is the provider's problem. If you're Google, if you're Amazon, Microsoft, whomever, you're responsible for providing the physical facilities, the services that you run out of those physical facilities, right? You guarantee via, the various compliance regimes that that you attest to, like SOC 2 and so forth, that you're delivering those services in the way that you say that you are, right? Like, for example, you've got, the right kind of card access control and man traps to make sure that some random person from the street can't walk into a data center, for example. And you've got all the other myriad of layers of control that you're using to deliver those services securely from whatever data center locations you provide. So as a consumer, as I'd imagine most of the audience of the podcast would be, you're basically you're trusting that your providers are delivering those services in the way that you say that the way that they say that they are. And so you're just kind of taking a dependency on that bottom layer. On top of that bottom layer, though, there's two more layers that are your responsibility as a customer. The first one is basically the service plane or the service management layer, which is to say, how am I consuming and configuring the services that I'm getting from that cloud provider? And how am I making use of the telemetry that I get from that cloud provider? So as an example, Amazon runs US East 2, right? That's the physical layer. That's the equipment that they have in that data center. That's that bottom layer in terms of what we were talking about a moment ago. Within that region, they're also going to deliver services, for example, like EC2 or EKS or ECS or many of the other 100 plus services that they have. You as a customer could configure ECS or EC2 either well or poorly from a security standpoint, irrespective of what Amazon's doing. For example, like Amazon can give you all the kinds of controls and capabilities that they promise around EC2, but if you put that instance into a VPC that doesn't have a security group associated with it or allows, anonymous access from an IAM perspective or something along those lines, even though Amazon is doing what they're supposed to be doing, you can still have an insecure EC2 instance because you have configured it incorrectly. And that service plane layer is what's often referred to in the industry as around cloud security posture management. Basically, how are you configuring those services appropriately to make sure that they're running with a secure configuration, even if the provider is doing everything that they're supposed to be doing on their part. On top of that, though, the other layer of cloud security is what are you running from a compute standpoint on top of those services? So that's like, what is the host OS that you install? What are the application frameworks? If you're using containers, what is a container runtime? Does it have vulnerabilities? Do you have some kind of active, response and detection capability at that layer? So again, to follow our example there, Amazon's doing everything they're supposed to be doing to manage EC2. You're utilizing some kind of CSPM technology, for example, to make sure that you have configured EC2 correctly, so that instance is in a VPC with a proper security group, IAM roles are correct, et cetera. Now, what are you installing from a host OS standpoint? If you're installing Ubuntu 14, for example, you've probably got lots of critical vulnerabilities with it, right? Inside of that, if you've got some application framework, like an old JDK, you may have other vulnerabilities. Maybe you've installed a Docker runtime and configured it insecurely. Or maybe you've done all those things without vulnerabilities, but yet there's some OData that's discovered in your application, and now somebody's trying to execute arbitrary code within that instance. Do you have something that's going to detect that tampering and be able to prevent that malicious software from running? So the third layer that runs on top of all that is that compute layer. How are you protecting the compute that's consuming the services that are being provided by your cloud service provider? So those three layers, when I think about cloud security, that's to me is the kind of conceptual module. The bottom part is the cloud providers and their problem. The second part is how do you configure those services? And the top layer is what's the compute that you're running on those services? Like almost everything else in security, you've got to be able to have assurances and controls at every layer because security is really all about defense and depth. And so a really comprehensive security strategy for the cloud is going to incorporate controls and protections at each one of those layers.
Yeah, and you're really highlighting that, sure, the cloud service providers have that bottom layer, but that shared responsibility model means a DevOps team, developers, just organization, you're responsible for these other two, as you're describing them. And that responsibility has to get pretty tough though, because you're describing not only, there's a lot of pitfalls, there's a lot of ways to mess up the misconfiguration of your containers, how your Kubernetes in the cloud, wherever it's deployed, but also, you were pointing out the operating system or the packages, and then we didn't even get really yet into the code that's running within in those containers. So then, what does it look like for developer or DevOps teams to try to get a handle on this? Because if we're looking at the cloud providers, they have a long list of all the services they provide from from lambdas to cloud functions, trying to stay neutral here in clouds. But I guess what I'm getting at too is I'm being overwhelmed already by these layers. How do we keep DevOps teams from being overwhelmed about just how much they have to test or check and QA, and what does a solution look like for them that's going to be successful? And I think that successful part is the key thing that kind of looking for here.
Yeah, well, I mean, the good news is that cloud and cloud native technologies provide you at least the opportunity to do security more efficiently and more effectively, because you can leverage the way that underlying tech stack works to have better security controls throughout the lifecycle. And that ability to have better security controls throughout the lifecycle means that you can find and fix problems a lot earlier and just with a lot less pain than you were able to do in the past. And so like a really specific example of that is the fact that you now really have an easy ability, because you have this consistent artifact of a serverless function or of a container image that your developer teams are going to build, and you're going to run that same thing unchanged in production. You have the ability now to say that when you build it, integrated with that same CI process, so you don't have to run a different tool, you don't have to install any software, or, take an additional manual step. Every time you do a build, you can assess that thing that you're building for vulnerabilities and for compliance, and you can see those problems right there where you're doing the build. And even if you choose to, maybe you even want to create a step that will fail the build if it doesn't meet the requirements, or maybe if it has like a critical CVE associated with it. And that allows you to be able to find those issues earlier and to find those issues via automation. If you think about the way that developer security historically has been, a lot of cases it relied on a lot of manual efforts. You build your application, then people would have a completely different set of tools they'd use to do, fuzzing or DAST or SAST or whatever it was that they were looking at. As the application stack has evolved to today, I think, probably being like 80% of the software that you're running is actually open source software that's being created, by some project on the internet. So the need for you to provide that kind of like, application security testing that you've done in the past and that classical way is really changed, because now you're able to look for found vulnerabilities in that stack. You're able to, again, find those problems at build time, so you can start addressing those things when you first start assembling the image, and thus prevent all the downstream places, your registry, when you deploy it, obviously your production environment, from ever being exposed to those problems to begin with. And that capability is not just at the application layer either. As you've seen, organizations really try to take more of an infrastructure as a code approach. Basically the ability to always be defining their cloud infrastructure as software, via CloudFormation templates or Terraform, or, even at a higher level abstraction with like a Helm chart or Kubernetes YAML file. You're basically enabling them to also provide that same kind of control at the infrastructure layer. So when you do a build, and that build includes, here's my application software that's going to run as container images. I've got a Kubernetes or a Helm chart that's going to define how that's deployed on Kubernetes. And then I've got CloudFormation or Terraform or something that's going to actually deploy the infrastructure that's going to run on. You can now have that sort of capability to scan for vulnerabilities and compliance problems throughout that entire stack. So you can look for those problems, not just at the application layer, but also look for insecure configurations of the infrastructure as code. So, going back to our 3-layered analogy, you can address those 2 layers that are your responsibility as a customer through this automation and integration with your build process, where you don't have to go and install manual tools or be reliant upon some external team to tell you whether or not you're building your environment safely and you're building your application safely as well.
Yeah, I find that infrastructure as code a really, really compelling case. And I'm kind of curious, too, because you've been describing a lot of build time validation, possibly even breaking the build, but moving into the DevOps workflow. How do you see this, or how have you seen this being approached by security teams, or who have you seen driving this, in the sense of, are DevOps teams actually the ones driving this, an engineering team driving this and seeing value out of these capabilities, or is it more of the security team coming by either with a, hopefully not in this day and age, but more of a checkbox that say, you must pass this before you can, deploy to production, or here's something that we're going to position that can make your life better, but we have to figure out how to explain that. So, where's that value that the developers are seeing out of these tools, being able to look at their workloads, for example?
Well, there's no single answer to it. I mean, we have customers that come at it from different perspectives. I think it just sort of depends on your organization and basically like the way that you have evolved over time. You know, if you have organizations with really advanced developer community, a lot of times they seek this out because they want to be able to find a tool that works for them and not wait for that security team to come and force them to use something, right? So sometimes the developer team is doing it because of, you know, self-interest or, you know, maybe even altruism where they want to really be doing the right thing. So it doesn't have to be led by the security team. In other cases, maybe the security team is the one that's really trying to kind of pull the development team along and to get them to utilize more modern approaches for application security. And they want to make sure that they're not exposed to those problems in production, that their developers are able to find those and fix those as they build the application versus after the application's been deployed. There's not really a right or a wrong approach to it. I mean, either approach can work. I would say, though, the one kind of guiding factor with that is you have to have both communities involved for it to be successful overall, right? The security team can't just force developers to try to use it against their will and expect to have a good result, right? That you know, they're not going to integrate it to all their builds, or they're going to find ways to work around it. And similarly, if the development team cares about this, but the security team is checked out, they're not going to have the visibility on what the impact actually is at runtime and how can they have similar kinds of controls at deployment time and at runtime for their applications. So the best way for this stuff to work is for both the developer team and the security team to be partnered on this, to have kind of a shared goal of reducing security exposure by finding and fixing problems earlier in the life cycle. That's going to be the best outcome for everybody.
I'm curious, do you find that you generally get people coming at you that are already educated on this? You know, they've got a checklist, they know what they want. Or do you still find yourself having to do a lot of education, on like your layered shared responsibility model, and on how these products integrate into that development workflow?
I think most people get it. The problem is that, if you're a large organization, in many cases, you've got literally decades of IT decisions and infrastructure and investments behind you, which means you've got decades of constraints and weirdness that you have to deal with. I often joke with people that, like, within IT, complexity is never created or destroyed; it's just moved around. So people love the cloud because it allowed them to get out of their old data centers. But even today, a lot of cloud deployments were just like picking up your mess from your own data center and moving it as IaaS to somebody else's data center. So yeah, you don't have to worry about the physical equipment anymore, but you still have the same kind of confusing or poorly designed, maybe stack of software and infrastructure that you're running. So I think it's less about awareness and more about just like the practical reality for people is it can be really hard to justify significant changes in their applications, especially things that are already deployed and already running and already out there. But the good thing that's, I think, or one of the good things, at least about cloud native, is the fact that it's not an all or nothing approach. It's not like you have to say, I'm going to migrate everything to containers for me to get advantages from utilizing cloud native. You can be very pragmatic about it and say, look, we've got this big monolith application. We wrote it in 2002, or we bought it then, or whatever. It's all like ancient Java on Oracle and so on and so forth. Well, there might still just be like a relatively small piece of that you're updating on a regular basis. Like maybe you've got something to do with like financial reporting, and you do that on a quarterly basis to reflect updates, or taxation you do every tax year, whatever it may be. Whatever that place where you're doing incremental changes are, that might be the place that you target trying to containerize or at least make cloud native that part of the application. And even if you still have a whole bunch of things that you might consider to be legacy out there, the part that's changing the most, you can at least get the benefits and the security advantages of providing those checks earlier for that part that's more dynamic, but dynamic and more actively being evolved over time. So, I try to tell people, don't think about this as like some huge migration where you have to accomplish everything that you want to accomplish at the very beginning just to get the advantages that you try to achieve from this. You can be a lot more incremental and pragmatic about where you want to apply those resources and start getting a return on that time right away.
Yeah, I think a lot of what you've been describing too is makes sense. Shift left, finding things earlier, using these tools to look at the posture, look at the configurations. And as you're describing the ideas of, the complexity that's simply moved around, I think that is going to resonate quite a bit with the audience as well. I'm curious too, when this complexity comes from the data center or whatever legacy that is into the cloud, what about the runtime side of things? There is still an aspect of the shift left may have missed something, vulns sneak through, or 0 days come out. So what are some ways that you would recommend too of either trends that you see or different ways of thinking or approaching these problems that people who are running apps within their data center might not be thinking of or appreciate that the cloud can do for them, or that can improve how they approach cloud security from that runtime perspective?
Well, it's a good question because security is always about defense in depth. I would never tell somebody just because you're doing vulnerability scanning at build time that you've got everything that you need from a security standpoint, right? You need to have those layers of defense in depth because invariably, as you said, there's going to be risks that are not addressed by one of the layers. You could build today, everything's perfect. You have no vulnerabilities. You deploy your application. Well, there could be not just an O day, but just a regularly discovered vulnerability in that application. And maybe you can't update it right away because you have other priorities, or you've got something else that's a change freeze or something that prevents you from making that change. And so for us, the way we look at the whole stack for cloud security is you've got to have multiple control points and multiple layers of defense in depth. And for runtime especially, I think one of the most interesting things that you can do is to leverage, again, those characteristics of cloud native to enable you to do security on a more efficient basis than you were able to do in the past. Cloud native applications are declarative, right? For the first time, every time you're building your app, you've got some parsable definition of what's in it. A Docker file basically that says start with this base layer OS, add this software, configure it in this manner. So you can really understand through software what something is supposed to be doing. They're also minimalistic. If you compare a traditional virtual machine, just the amount of bits required, it's tens of gigs versus a container image that might be tens of megs. And so it might be literally orders of magnitude less stuff that you have to analyze, which is really important because it has a huge impact on the overall efficiency and even just efficacy of the software's ability to determine where there's problems and risks. And finally, probably most important from a runtime standpoint is that cloud native applications are typically at least designed to be predictable at runtime. In other words, to do the same thing from build and ship to actually execution. And what that really means is that you can build software now that is able to establish a baseline, what we consider to be a referential model for the way that application normally should behave at runtime. We can look at this app and see that the application normally listens on port 80. It normally runs Nginx, which has this checksum. It normally writes this file path. It resolves names in this namespace, et cetera. We can create a referential model that predicts what that container that's running that image should do throughout the course of its life. And thus you can really flip the way that you do security at runtime from being running around with a huge list of every possible thing that could potentially be bad to saying we know that the only things it should do are this, and thus anything else that's outside that model, we're going to automatically prevent. So, kind of the notion of zero trust networking, it's kind of like zero trust runtime security, where you're saying we've learned all the things that are normal there, and we're only going to allow those things. Now, you've heard security vendors in the past talk about some, variant of zero trust for runtime, and it's been technically possible to do in the past, but practically impossible to do in the past. And the reason it was technically possible is you've got various controls in the Linux kernel and Windows, and file system permissions and user roles and C groups and so forth that you can use to constrain what a given application can do. But when you're having to configure that entirely manually, there's really no practical way that an organization is going to be able to stay on front of application development so that they're not slowing it down to be able to create those policies. Whereas now, again, because of that declarative, minimalistic, predictable characteristics of cloud native applications, you can have software do that for you. And obviously, software is much more able to keep up with that rapid innovation that your development team has. So it's that combination of those characteristics of cloud native applications combined with software that leverages them to automatically model the way that applications should behave that gives you the ability to have that zero trust approach to runtime defense for those cloud native apps.
Yeah.
So, do you think is that a solid approach? I think you mentioned earlier, or at least referenced the fact that a lot of the code running in these cloud native apps is not proprietary code. They're libraries and things that come out of repos, and there's a lot of trusting going on there.
Yeah.
That NPM and gems and all these dependencies that we're leaning on in this code is trustworthy. So I mean, is that you're creating these baselines saying these are the only things that can be run. So presumably it sounds like if a backdoor goes into one of my npm packages or something like that, I provisionally at least be protected from that, but do you think that's a starting point to address those kinds of concerns?
It's a starting point to address it. I mean, the point that you raise is entirely valid, right? You're always going to be, so I don't want to say at the mercy of, but your security is ultimately going to be derived from the software that you've chosen to run, especially if it's software, that you didn't create. It's possible it could be poisoned or backdoor in some way. One of the promises of open source, of course, is, that many eyes philosophy that you should, many people are using it. You should be able to find problems with it. But, regardless, it's a very key point. I think it's one of those just structural matters that you have to understand about security. A lot of times I have this conversation, especially recently with SolarWinds, and I always point people back to Ken Thompson's paper back in 1984 on trusting trust, which is basically to say, you inherently are trusting the software of others when you're running their bits, basically. Realistically, there's nothing that you're going to be able to do about that. The way that modern software works, you have to be dependent upon others, be that a open source project, a commercial vendor. And, clearly not just because something is commercial means that it's inherently more secure than something being open source. So I think for all these things, it's a matter of having, again, layers of defense in depth. One of the things that we think is an important control that we provide is the ability for you to trust a certain set of images upstream. So you can say, look, in my environment, I don't want to allow people to run software except for things that come from some pipeline or some repositories that I have deemed to be trustworthy. I've investigated them, or reputationally, I believe that they're secure. Maybe they come from a partner whom I have a commercial relationship with, like a Red Hat or something like that. And that's the only software that I'm going to allow to run in my environment. So that's one layer of control that you have for that. And additionally, another layer of control is we don't look at runtime as being exclusively just the model-driven predictive approach to preventing behaviors, but also to have a threat indicator element. So let's say, like in your case, you download and you run some image that you consider to be trustworthy, but somehow it's been poisoned and there's some kind of let's say a crypto miner in it, or something else that's in there that we know to be abnormal, even if it's part of the original image. We also have additional layers of defense there because we've got threat intel signatures where we can say, look, even though this thing doesn't seem to be running a process that's unexpected, we nevertheless see it connecting to some command and control system on the internet. Or, it seems like it's an image that's from a place that you trust, but look, it's also running like well-known crypto mining software, or even maybe not well-known crypto mining software. And so it's not simply about just saying like the model is the only thing, but the model is the first thing that we apply, and then we can supplement what the model predicts or doesn't predict with that runtime threat intelligence. And I think that gives you a good balance there of not just giving you that zero trust approach, but also saying beyond what you trust and think is normal, here's also indicators of threats about things that you might consider to be, a normal image that's actually doing abnormal activities.
Yeah, and I love that you point out that this has been possible for many, many years, applying this principle of least privilege to runtime environments, but not practical. I remember the first time somebody pitched microsegmentation to me, and my first question was like, how is this not like going from managing 8 firewalls to 8,000 all of a sudden? Like that's the problem I'm afraid of here. That now I've got 8,000 individual policies, to manage here, and I've got to figure out what those policies are, for all these.
Well, and I think that's why, like, it can't be something that you create the policies, right? Like that's the whole idea with this is like these models are automatically created every time you see an image for the first time, and that model is correlated to the SHA of the image. So you don't have to worry about concurrency and, well, does this, model that we created for this old version of the image work with the new version? Literally every single image that we see, we create a new referential model for that image, irrespective of whether or not there's some previous image that basically did the same thing in the same repo and just flip one bit in it. It's still a new image, thus represented by a new SHA, and thus gets a new model. And all those models are something that's created automatically. There's no human supervision. There's no human, interaction that's required to do that. And again, we're not saying that that's the only thing that you need. We're saying like everything with security is defense in depth. And part of that defense in depth is if we can automatically create these predictive models that say like, this is what we think this thing should normally be doing, you can squelch a lot of noise and identify a lot of potential problems without you having to go through the effort of, figuring out how do I create manual policies for every single thing that I build within my environment.
Yeah, absolutely. The underlying theme there is scaling and confidence in the repeatability, I think is how I would express that. Because while you're describing that, I'm trying to mentally go through and figure out how hard it is to configure just an eBPF policy for one container image for one app.
Exactly.
And my mind just breaks trying to then repeat that over and over. I'm curious, John, as we've been talking about this, we've covered a couple areas in the sense of, shifting out of the data centers into the cloud or starting up native in the cloud. I'm kind of curious, maybe to close out a little bit, what have you sort of learned as you're building these solutions, either for the cloud or for DevOps teams, modern DevOps teams? Something that is a lesson learned for security, whether it's an internal security org building service for their own organization or vendors, things like that. Just understanding this is the modern way of approaching a platform or a service that gives value to the developers at the end of the day.
Well, to me, the biggest lesson with that, and this was something I tried to even institute, as a CISO before we started with Twistlock, was if it's not a automated process, then you may as well not even have it at all. Because to try to expect today, with the amount of systems that people have to deal with, the amount of diversity in the environments that they're challenged with, and just the amount of threats that they encounter on a day-to-day basis, if you're requiring like manual one-off effort to review a log or to take an action or something like that, you've already lost, right? I mean, like you've got to be able to make sure that the system is able to enforce quality and security controls, again, throughout that life cycle we talked about earlier, so you're able to avoid problems before they ever get to production in the first place. And that when you're trying to protect things in production, that you're not relying upon people manually creating rules or manually creating policies or manually reviewing a bunch of logs. Obviously, there's always going to be a human element involved in dealing with sort of like the unknown situation. But if you're utilizing or building good security software, one of your foremost objectives should be to squelch as much of that noise as possible, so that those human beings that are actually responsible for looking at what's left at the end of that filter, they're actually looking at things that require some, human intelligence to be able to figure out what to do and what the results of that rule are. And so I think the biggest takeaway to me is that whatever you build should be something that can be systematized and automated, so that you're not dealing with manual interactions or manual choke points along the way to being able to either prevent things or to react to things that occur within the environment.
That's a great message. And I think you squelched quite a bit of noise here and gotten through a pretty clear signal, and I think a helpful signal too for organizations moving to the cloud. So just want to say once again, thank you very much for joining us, John.
You're welcome. Thanks for having me.
Also want to say thank Adrian for joining us in as well, and thank all the listeners. If you'd like to learn more about Prisma Cloud, visit securityweekly.com/Prisma Cloud. It's now time for our intermission, and we'll return with news of the week.